Welcome, everyone, to the Explainer. Today, we're tackling a total game changer for manufacturing lines, error-proofing work cell assembly. Let's face it, discovering a missing piece during an end-of-line test is exactly what we all want to avoid. So we're going to explore how automating your manual verification steps has quickly become one of the absolute highest return investments you can make on the plant floor. Here is our roadmap for today. We're looking at the verification bottleneck, the 3 layers of automation, the hardware driving it, anomaly detection and integration, and finally, the big 3 outcomes. All right, Section 1, the verification bottleneck. We really have to ask ourselves, why is assembly verification such a massive bottleneck in the first place? Well, in most work cells right now, verification is still incredibly manual. An operator physically scans components against an order as they install them, and then does a final visual check before pushing it down the line. But let's be real, staring at hundreds of the exact same parts over a 10-hour shift, that is a literal recipe for fatigue. Every one of those manual touches becomes a bottleneck purely because of the human element. It's honestly night and day when you compare them. Manual work cells are just inherently prone to human error. When operators are under intense quota pressure, relying on memory means skipped scans, grabbing lookalike parts, and rushed checks. It puts a hard cap on how much you can scale. But automated work cells, they replace all those human variables with objective gates. You get repeatable results, infinite scale, and you completely take that mental burden right off the operator. Because here's the thing, when a bad assembly slips through, the cost just snowballs downstream into expensive rework, scrap, or lost revenue. And as the old saying goes, adding volume just adds more opportunities for the exact same errors. You can't outwork a bad process just by throwing more human inspectors at it, you know? You absolutely have to automate the verification itself. Moving on to Section 2, 3 layers of automation. Zebra actually breaks this process down into 3 coordinated layers. Each one answers a different question at the workstation without ever messing up the operator's rhythm. Step 1, capture the component data. Step 2, guide the operator. And step 3, finalize those quality checks. Let's look at that first layer, capture data. As a component is installed, it's instantly scanned to verify it against the production order. Operators might use a rugged handheld for this, or maybe fixed mount scanners. And these things can decode ridiculously tough marks. We're talking high-density barcodes on tiny subcomponents or laser-etched direct part marks, or DPMs. Imagine a barcode basically tattooed onto shiny metal with almost zero contrast. Boom. Verified instantly without skipping a beat. Then we have layer 2, guide workflow. Instead of relying on memory or those paper travelers that always seem to go missing, this layer gives you a digital production order. A tablet anchors the workstation, giving step-by-step visual instructions and confirming every single scan as it happens. It guarantees everything is done in the proper sequence. So if layer 1 verifies the part, this layer verifies the process. It stops sequence errors before they even happen. Okay, Section 3, the hardware driving it. To actually build this automated cell, you need the right tools. Automation distribution carries the whole Zebra portfolio to anchor these layers. Whether your setup uses manual bins, hands-free presentation points, or even complex 3D verification. From the super tough DS3600 series handhelds to the wildly advanced AltiZ 3D profile sensor, there is quite literally an engineered solution for every possible inspection need. It's amazing how specialized these tools get based on exactly what you need. Moving between bins, the DS360 handheld is your go-to. Need a hands-free setup reading really tough DPM codes? You step up to the FS40 or the FS42 with its quad-core processor. Or maybe you need to measure the exact 3D flushness of a seated component. That's where the AltiZ 3D profile sensor comes in. Every physical challenge on the floor has a tool built exactly for it. Now, hearing all that, you might be thinking, okay, managing all that different hardware sounds like a complete integration nightmare. But actually, scratch that. It's incredibly simple. Despite the massive variety of hardware, there is one unified toolchain. The Zebra Aurora Focus software platform configures and manages every single automated verification point in the cell. The whole shebang is in one place. No jumping between 5 different software interfaces. Which brings us to Section 4, anomaly detection and integration. Historically, machine vision meant programming a strict rule for every single possible defect, which, let's be honest, is practically impossible. But anomaly detection totally flips the script using deep learning. It's kind of like a super fast game of spot the difference. You just show the system an image of a known good, perfectly completed assembly. Then, a sensor like the Zebra NS42 uses its onboard processing to instantly compare live assemblies against that golden reference. It automatically flags a missing clip or an unseated connector without you ever writing a single rule for it. Pretty mind-blowing, right? Of course, an automated check doesn't mean much if it can't talk to the rest of your line. To skip the integration headaches, these smart sensors plug directly into your work cell's PLC, basically the central nervous system of your machinery. Out of the box, they support heavy industrial protocols like Ethernet/IP, Profinet, and Modbus TCP. They're built to just slide seamlessly into your existing controls architecture. And because of that deep PLC integration, the system can physically gate the process in real time. If the sensor spots a missing connector, the PLC can literally disable the operator's torque tool on the spot. It physically stops them from moving forward. It can hold a transfer line or trigger a reject diverter. It guarantees, absolutely guarantees, that a defective unit cannot move down the line based on instant pass or fail results. Finally, Section 5, the big 3 outcomes. So what is the bottom line here? 3 profound outcomes. First, improved quality management. Every assembly passes the exact same objective gates. No fatigue, no memory lapses. Second, better traceability. You're building permanent, serialized records for compliance. And third, enhanced production efficiency. The verification that used to bottleneck your entire cell, it now runs at the exact speed of the work itself. I really want to highlight this traceability upgrade because it is a massive win for liability and cost control. Since every component scan is verified and written against the production order, you get a serialized record of exactly what went into every single assembly. Think about it. If a vendor tells you they had a bad batch of parts 3 months ago, there's no more blind panic, no costly batch-wide quarantines. You just target the exact serial numbers affected. That capability alone usually pays for the entire investment. So here's the final question to chew on. Are you ready to let your operation scale without scaling your error rate right along with it? Every single day you rely purely on human inspection, you're leaving your throughput to chance. If you are ready to stop paying for those same repetitive errors and actually error-proof your workflow, checking out these Zebra Machine Vision solutions with automation distribution is your essential next step. Thanks so much for joining me for this explainer, and I will catch you on the next one.